Hello, Matthews Gatos here. In this video, we are going to cover the product law. But before I do that, I just want to review with you the power rule. So when we had the power rule and we wanted to take the derivative of this function, the first thing I would do is write my x with exponents instead of roots. So then I'm going to simplify my function. If I simplify my function, I simplify the derivative. So distributing that in, x to the 1/2 times 2 is 2x to the 1/2. X to the 1/2 times 3x is 3x to the 3/2. So now that my function is simplified, I'm ready to take the derivative. So the power rule says bring my exponent down, multiply it by the 2x, and decrease my exponent by 1. Bring the 3/2 down, multiply it by the 3x, decrease my power by 1. 3/2 take away 1 is 1/2. So tidying this up, I have half of 2, which is 1, x to the negative 1/2, minus 3/2 times 3 is 9/2, x to the 1/2. So now I can factor out a greatest common factor. I see that both of my terms have a factor of x, so I will take x to the smaller exponent. And then I notice that my second term has a fraction, so I'm going to actually take out a half because I don't want to be left with a fraction when I factor. So in front of this is a 1. 1 divided by a half is 2. X to the negative 1/2 divided by x to the negative 1/2 is 1. Then I have take away 9/2 divided by a half is 9. And x to the 1/2 divided by x to the negative half is keep the base the same, subtract the exponents. So 1/2 take away negative a half is 1. So back over here, in the numerator, I'm going to have 2 minus 9x, which is a negative for my leading coefficient. So I'm going to factor out a negative because I want my leading coefficient to be positive. And then in the denominator, half means divide by 2, square root of x. So that would be my derivative using the power rule. Now we're going to come back to this answer and we're going to solve this question using the product law. So what is the product law? The product law is a way to take the derivative of, you guessed it, a product. So if I have f of x and g of x, they are both differentiable functions. Then to find the derivative of the product, I do the derivative of the first function times the second, plus the first function times the derivative of the second. Now that's the calculus definition. Let's look at a way that I like to do the product law. So I like to have a hook or a way to remember things. So what I'm going to do is I'm going to say that 1d2 plus 2d1, because calculus is so much fun. So I like a little rhyme to help me out to remember things, especially when that rhyme is true. Calculus is so much fun, and it rhymes with 1. So what does this little rhyme mean? Well, 1 stands for my first function. D2 stands for the derivative of the second. 2 stands for my second function, and D1 stands for the derivative of my first. So let's go back and solve that same question using this time the product law. But after we do the product law, something I want to note, you're either going to factor a GCF or expand and simplify. Those are your two choices once you apply the product rule. So let's go back to that same example. This is the answer that I'm hoping to get. That's what I got when I used the power law or the power rule. So let's look at the product law. So my first function is the square root of x, or x to the 1/2. The derivative of that is 1/2 x to the negative a half. Okay, my second function, the second function in my product, is 2 minus 3x, and the derivative of that one is negative 3. So let's apply the product rule. Now I'm starting with f, so I'm going to do f prime of x, and then I apply my little rhyme. So I have 1 d2 plus 2 d1, because calculus is so much fun. Okay, so as soon as I apply the product rule, remember I said I have those two choices. I either factor a GCF or expand and simplify. So I'm going to factor a GCF. So I notice that both of my terms have x, and I'm going to take out x to the lower exponent, which is negative a half. They also have numbers, negative 3 and a half. I don't want to be left with a fraction, so I'm actually going to take out a half. So let's divide that by each of my terms. So 1 in front of here, actually, negative 3 divided by a half is negative 6. X to the 1/2 divided by x to the negative half is keep the base the same, subtract the exponents, plus 1/2 divided by a half is 1. X to the negative half divided by x to the negative half is 1. I'm left with just 2 minus 3x. So keep everything the same on the outside and then simplify the inside. So I'm going to have negative 6x take away 3x is negative 9x plus 2. And you see I arrive at the same point I was before. So to make this a positive, I take out the negative to make my leading coefficient positive. And the divide by 2 root x. And you can see I get the same answer in what I think is a little bit of an easier way. So now that we've done product law, let's try another one. So in this one here, I could expand and group like terms using my power rule, but I'm just going to, again, practice with my product law. So 1 is my first function. D1 is the derivative of that, 6x squared. 2 is my second function, and D2 is the derivative of that, 6x minus 1. Okay, so now I'm ready to do my derivative. So since I started with y, I'm going to call this one here y prime. So I'm going to take 1, multiply it by d2, which is 6x squared. No, sorry, it's 6x minus 1. Let's try that again. 6x minus 1 plus 2, which is 3x squared minus x, multiplied by d1, because calculus is so much fun, 6x squared. Okay, so again, I'm faced with that same question. Do I expand and group like terms? Do I factor a GCF? Looking at my two terms, I can see I do not have a GCF. So I'm going to expand and group like terms. So 2x cubed times x, 12x to the exponent of 4. 2x cubed times negative 1. 5 times 6x, 5 times negative 1. Plus, over here, 6x squared times 3x squared, 18x exponent 4, and then negative 6x cubed. So writing this in descending powers of x and grouping my like terms, I have 30x exponent 4 and negative 8x cubed plus 30x minus 5. So that would be my derivative. Let's try another example. So this one here, again, I have a product, so I'll just identify my first, which is 6x. The derivative of that is 6. My second function is 3x plus 1 cubed, and the derivative of that would be 3 times 3x plus 1 squared, don't forget chain rule, multiplied by 3. So f prime of x is 1 d2, let's just simplify those, 3 times 3 is 9. So I've done 1 d2 plus 2 d1, because calculus is so much fun. Are you having fun? So 6x times 9, 54x, multiplied by 3x plus 1 squared, plus 6 times 3x plus 1 cubed. So again, I'm faced with that choice. Do I factor a GCF or do I expand and simplify? Well, here you can see I have two terms, and they do have a GCF. So let's take out the GCF. So first thing I know, 54x and 6 have a GCF of 6. And then I see 3x plus 1 is a common binomial. I'll take it out to the smaller exponent of 2. So 54x divided by 9, or sorry, divided by 6 is 9, 9x. 3x plus 1 squared divided by 3x plus 1 squared is 1, plus 6 divided by 6 is 1, and 3x plus 1 cubed divided by squared is just 1 to the exponent of 1. So let's tidy this up. I have 6 times 3x plus 1 squared multiplied by 9x plus 3x is 12x plus 1. And then I just look to see, can anything else be simplified? And I don't see anything else to be simplified, so that would be my derivative. Okay, let's try another one here. So another product. So my first function is x squared. The derivative of that is 2x. My second function is x cubed plus 1 to the 1/2. The derivative of that is 1/2 x cubed plus 1. Decrease my power by 1, but this is chain rule, so don't forget to multiply by the derivative of the inside, which is 3x squared. So my derivative is going to be 1 and then d2 plus 2 d1, because calculus is so much fun. Okay, let's tidy this up. So looking at everything here, I have half times 3 is 3/2. X squared times x squared is x exponent 4 times x cubed plus 1 to the negative 1/2. Plus here 2x times x cubed plus 1 to the 1/2. So again, decision time. Do I expand and group like terms, or do I factor a GCF? So looking at my two terms, I'm going to go with factor a GCF. So 3/2 and 2. Well, first of all, I notice there's a fraction. I never want a fraction, so I'm going to take out the half. I have x exponent 4 and x, so I take out the smaller. And then I have x cubed plus 1 to the smaller exponent, negative 1/2. So 3/2 divided by 1/2 is 3. X to the 4 divided by x is x cubed. And these two divide to be 1. Plus 2 divided by 1/2 is 4. X divided by x is 1. And then x cubed plus 1. When I divide those, I keep the base the same, subtract the exponents, so half take away negative 1/2 is 1. Okay, so let's tidy up what we have inside the brackets. So we have 3x cubed plus, distribute this in, 4x cubed plus 4. Almost there. I feel the finish line is in sight. I'm just going to simplify what I have on the inside, which is 7x cubed plus 4. So final answer, getting rid of my negative exponent, I'm going to keep 7x cubed plus 4 in the numerator, multiply that by x, divide by 2, because 1/2 is divided by 2, and then I'll bring the root down to make it positive, and I'll write it as a square root. Because I started with square roots, I'll end with square roots as well. So that is how I do that product. So I just want to end with back to tangent line. I don't want you guys to forget what the whole point of derivatives is. So the point of a derivative is to find the slope of a tangent line to any curve. That's what it is in general. So in this one here, I want to find the slope of the tangent line to this curve at this point called the point of tangency. Now let's list this out. I'm going to do the derivative. So to do the derivative, I want to identify my first function, 3x squared plus 2, and then the derivative of my first function is 6x. My second function is 2x cubed minus 1. The derivative of that, 6x squared. So the derivative is 1 and then d2 plus 2 and then d1, because calculus is so much fun. Now, normally I would expand, group like terms, or factor, but in this case, I just want slope as a number. So I have a little note there for you. If you want a numeric value for slope, after you take the first derivative, just substitute your value in. Less chance of making errors. So if my tangent point, my point of tangency is 1 and 5, I'm going to substitute in x equal to 1 to find the slope of my tangent line at x equal to 1. So I'm going to have 3 times 1 squared, which is 3. 6 times 1 squared, which is 1, 6 times 1, plus 1 cubed is 1 times 2, and 6 times 1 is 6. So we'll do a little math-a-magic here, multiplying all these numbers together. And I get 30 plus 6. So the first derivative at x equal to 1 is 36. So that tells me the slope of the tangent line is 36 at that point 1 and 5. So I always want to come back to that tangent line so that you recognize that's what we're doing with derivatives. So remember, product law, 1d2 plus 2d1, because calculus is so much fun. So do you think calculus is fun? Or is calculus driving you mad? Hopefully, it's the fun answer. So I hope this video helped. If it did, give it a thumbs up so I can help more mathies like you, and I look forward to seeing you for the next one.